Good afternoon and welcome to today's class. We want to start our class as usual, and of course, we are going to start from where we stopped. The last time we talked about swords in the last class, and I was expecting that there will be questions that people will send so that we can work with more questions, but I think the explanations were okay enough, so there were no questions sent, and it's fine that way. So this week, we can just quickly go to another topic. So far, so good. We've treated number basis, we've treated approximation estimation, we've treated sorts, and I think it's high time we go to set theory. So to set theory. Okay. Set is simply classification of objects. When we talk about classifying objects, distinct object has to be distinct. It's not just generally. When we talk about set of specific, when you are talking about sets, because a lot of things can be related in a way. But when particular characteristic that of objects, set theory is all about. And for the sake of brevity, we're going to be talking about the major means of representing sets. We have three modes of set representation. We have what we call the listing form. So representation of sets. So we have the listing form where you list the particular set you're talking about. Then we have builder form. Builder, this is number 2. Builder form. I can call also this one listing form. Listing form. And then the third one is the general one we call a Venn diagram. Venn diagram. Venn diagram. So these are the three major modes of representation of set theory. So we are going to come back to all this, but definitely this is where we're going to climax on this topic. All right. I said set is classification of distinct objects. Now, there are ways we need to know when you have a set, how do you present your set? You present your set in this format. You let a particular capital letter, anyone, represent your set, and then the set must contain entries, or what we call members or elements. I've mentioned 3 things. For each set, there must be what we call entries or members or elements. All right. So these are what makes up the sets. If you want to represent those sets, members with letters, you are going to use small letter cases. All right. So we can have such. And then you are going to open and close with special brace, special curly brace character. You don't use this kind of thing for set representation. No, it is not allowed. You use special curly brace or special brace anyhow, but it is not the normal bracket that we are used to. All right. So if I want to talk about set of vowel sounds, set of vowel sound, I can use capital letter V to represent my set of vowel sounds. Then, of course, A, he, I can use a comma to separate them, I, O, U. So here we have set of vowel letters. Now, in this case, that I have set of vowel letters or vowels, simply called vowel. In this case, what I've done is that I've listed out the actual letters that represent my vowels. So that is listing form. That is number one. That is one way of representing vowels, listing form. If I decide not to list the vowels, I can actually think of another way of representing my vowel letters. And let me show you that here. I can just simply say that my V, my V is equal to, let me take away this. Yeah, something like this, set of vowels. Now, what I've done, this one representing number builder folder notation. I have not told you what vowels are. I just said they are set of vowels. So in this case now, you will not be the one to think what are vowels. You will now slot in those exact things that are vowels. Another example, let me give you. If I talk about P, say P is a set of I want to switch to numbers now. P is a set of prime numbers between 1 and 10. Prime numbers. Prime numbers. Prime numbers. Okay. Let me just use 1 and 10. All right. So P is set of prime numbers between 1 and 10. This one is called builder form because I didn't tell you what prime numbers between 1 and 10 are. I just told you they are prime numbers. So for someone that wants to now solve a question that will involve this kind of question, you need to actually interpret this statement by writing out the prime numbers between 1 and 10, and which, of course, prime numbers are numbers that has only two factors, itself and 1. And what are the numbers that we can think of that has two factors between 1 and 10? They are just 2, 3, 5, 7. These are prime numbers between 1 and 10. 2, 3, 5, and 7. They are the prime numbers between 5. So in most cases at the JAMB level, they will test you on this. They want to know whether you know what you're doing. All right. So they will test you a lot of questions. They can come in inequality formats. They can say T. I will just give you some, that because builder forms, students are not used to it most times. They can just say X such that 2x is less than 20. X, the set of, I will interpret it for you, don't worry. I'm just trying to put up a particular example, and I want to write it in such a way that it will be clear to you so you won't misinterpret my write-ups. 2x. Okay, 2x is less than 20. Yeah, this is beautiful. So, and then of course they can put what are the numbers that when you multiply by 2, I can give an additional information, comma, comma, that is 5 is less than x less than 10. This is actually nested information. So I'm looking for a set of number that when I multiply by 2, I must get a number less than 20. And that those number itself that I'm looking for must be between 5 and 10. So you can see that there are two conditions to every number that I must satisfy in this case now. This is builder notation. So if I want to interpret the set T now, so I have to think of numbers that, what are the numbers? I can think of a number like, of course, 6. 5 is less than 6. I cannot think is in negative. I have to think of a number in which 5 must be less than that number. 5 is less than 6. And then 6 times 2 is also less than 20. So 6 is qualified to be that number I'm looking for. The next number is 7. 7 is less than 10 too. And then 7 times 2 is also less than 20. So I'm fine to put 7. I'm also fine to put 8. I'm also fine to put 9. There is no other number that qualifies, because in the first instance, that number must be less than 10. So you can see that these are the numbers that I'm looking for. But they won't tell you it's 6, 7, 8, 9 directly. And that is the builder aspect of it. They will just present the set in another format. So you have to think of the exact set of numbers you are taking off. Okay. So the other type, which is the Venn diagram, I will describe that later. We are going to use that to climax. Then now let us talk about notation in sets now. Notation in set. There are different notation in sets that we need to know. So if I have something like this, of course, because I want to believe, or you have something like this. This is called universal set. Universal set. I'm not going to write everything word for word, because we are not just starting mathematics as a topic. It's for the sake of the exam. So it's more of a revisional guide. And then, of course, if you have A, you have this, apologies, it should be capital letter because I'm dealing with set. A intersection B. This is intersection, and this one is union. I'm not actually after the A and B. I'm after the notation in between them. Or maybe I should just ignore that protocol and just concentrate on the intersection and the union. So here you have intersection, here you have union, here you have elements, something like this. Yeah, and then here you have subset. Is either this or this. Both means subset, at least at this level. It means subset. When you are dealing with advanced mathematics, that one means something more than the other. All right. For advanced mathematics level, the first one is proper subset, while the second one is improper subset. But at your level of jump, you just need to know that it is a subset. So either they use the first or second one, it means subset. All right. Then if you have something like this one means complement. It will be a small letter C as a subscript to a particular set. Or they just write a dash or a little factorial notation on top of the letter. It means complement. And complement means what is not in that set but can be found in the universal set. That is complement. Then which other one? Okay, when you have this N of A, this is called cardinality. Cardinality simply means the number of elements in a particular set. So let me quickly just talk about this a bit. When you look at this last example we gave, that is set T, I can find the number of elements in T. I can do this, N of T. That's what it means. It means 4. That is, you count 1, 2, 3, 4. 4 elements are in the set C. 4 elements are in the set T. So it means the cardinality of T is what? 4. So please note that when you see N in brackets and then they put the set in between, it simply means the number of elements in that set. All right. So I can quickly move back to where I'm coming from. So that simply means cardinality. And then we also talked, okay, I'll come back to subset in a way. I'm just doing a brief introduction. Okay, I want to see what else I should talk about. Okay, so let me talk about the number of subsets in a set itself. Please note that every set is a subset of itself. That's one. So every set is a subset of itself. Also, there is symbol for empty sets. It's either you use this, or you see this opening and closing brackets, or you use just this symbol. Any of them can be used, but not both of them. So it simply means empty set. It simply means empty set. And just like I mentioned here, I'm going to use a red asterisk to show that it is actually an assumption we need to know. Every set is a subset of itself. Yes, that is why I put it in a star. Also, empty set is a subset of every set. I'm going to put that in the next slide. Empty set is a subset of every set. Very important. And I will tell you why I'm trying to hammer on that. Empty set is a subset of every set. Any set that is given, empty set is a subset of that. Now, if you want to know the number of subsets that a set contains, the number of subset that a set contains, let me think, my screen is acting funny, but it's fine here. The number of subsets, the number of subsets in a particular set, in a particular set is given by 2 raised to power n. Full stop. 2 raised to power n. Where n is the number, of elements, where n is the number of elements in the set. Where n is the number of elements in the set. I need to state this. I will go back to the set T that we used the other time. All right, I'll go back to the set T that we used. So the set T has 4 elements. So if I want to know the number of subsets that I will get in a set T, the number of subsets will just be 2 raised to power number of elements. So for n of t is equal to 4. Therefore, number of subsets in set T will be 2 raised to power n, 2 raised to power n, which is equal to 2 raised to power 4. And of course, I'll get 16. The number of subsets that I'll get in set T will be 16. 16 different subsets. So if I decide to pick set T and I take out each of the subsets, each of the set that I can derive from another set, because subset means a set that you can take out of another set. So the number of sets that I can take independently from another set T, I'll get 16 of them. 16 of them. So that is what we mean by subsets. Okay, so all these are necessary for us to know. And then the next thing we should talk about is that when we have 2 sets, of course, we can see that 2 sets can be related in the format of this. For any set A and B, A union B, union of 2 sets simply means combination of both elements in the set, whether the element is in set A or in set B, or in both set A and B. But there cannot be repetition. There cannot be repetition. So I think before I state the formula, let me quickly use a simple explanation. So let's say my set A is, I have A, B, C, D, okay, D and E. I think this is okay like this. This is okay like this. A, B, C, D, E. Okay. And then my set B will just be A, E, IOU. All right. So this is my set A and B. Now, I want to do two things for this one now. I want to do A intersection B. Now, intersection simply means what is common to both. So in this case now, I have A here and I have A here. I have E here and I have E here. So the only two elements that is common to A and B, which is intersection, is A and elements A and E. Element A and E. But when I'm talking about union now, A union B is combination of all the elements. So I'm going to have A, B, C, D, E, I, O, U. So I've combined everything in A and B together. But you can see that A repeats twice does not mean I should repeat it here. There must not be repetition. In any case, there must not be repetition. And then I want to use this to prove a point, and I will take time to let you look at everything you have on the screen and be able to use that to justify what I'm about to write now. So A union B will be equal to A plus B minus A intersection B. A union B is A plus B minus A intersection B. I'm still going to write this in another format. This is what we call the law of set algebra. I'm still going to write it in another format, which means the same thing anyway. This is when you are talking about the entire set. When you are talking about the entire set on its own. When you are now talking in terms of the number of elements, cardinality, all you need to do is just change the format to n of A. Okay. Union B is equal to n of A plus n of B minus n of A intersection B. Please note that the n that I am using here is not intersection, no, it's the normal n, which means number of elements. And then the one I'm using in between the sets, they are intersection. The n may look like they are the same. They are actually not the same. All right. The normal n retain its value as number, while the intersection can be something more special. So please, in case you are working on it, you need to learn the difference. All right. That's very important. That's very important because notation can be very confusing in mathematics. So I will always encourage my students to take extra care in dealing with notation. Very important. Very important. So take extra care in dealing with notations. I can tell you also that these two means the same thing. If you want to check, that's why I'm saying I'm going to be on this screen for a while. Now I want to use what I have on the A and B up there to defend what I have just written below here now. Let me start from the last equation I just wrote. N of A union B. If you count the number of elements in A union B, you will count 1, 2, 3, 4, 5, 6, 7, 8. There are 8. You count 8. Now, if you count the number of elements in A, you count 1, 2, 3, 4, 5. If you count the number of elements in B also, you count 1, 2, 3, 4, 5. That is A, E, I, O, U. So each of them contain 5, 5. But if you count the number of elements in A intersection B, you only count 2. You only count 2. What does that mean? It means that when you are combining two sets, the element of repetition or intersection or overlapping will be taken care of. That is what it means. The element of overlapping will be taken care of. Why? A is already in A is also in B. That does not mean we should write A twice. So the repetition, or what I call overlapping of that A, has been taken care of in the combination, in the union of set A and B. And the same thing that happens to E, it has been taken care of. So in order not to cause confusion is why we have all of this here. Very important that we should note that. Okay. I would have loved that we should just start picking questions. There are a lot of questions, but I want to take my time to explain the concept of okay. All right. So let us do some things. Let us do something. I've already explained the concept of complement. So I want to solve questions. I want to solve question now. Before I go to the third one, which is actually what we are going to use to climax the topic. I don't know if we have the luxury of time uh to work on it, but it's fine. If we can't, we'll just dedicate next class to Venn diagram. Okay, so let's see this question. This question is a 2003 question. 2003 question, JAMB 2003. So example. So you can check your 2003 question, but I'm going to read what is there. Given U, that is universal set, is even numbers between 0 and 30. Even numbers between 0 and 30. Then P, multiples of 6 between 0 and 30. Q, multiples of 4 between 0 and 30. They now ask us to find, let me just do some, I'll do some shorthand representation of that. Given, because when we have to write all of that, given that U equal to even numbers, even numbers between 0 and 30, that is the universal set. Then they now give us P. I will just encourage you. I think we have about I don't know. I think we should have close to 10 minutes left. Okay, let me see. I will just rush to solve this. Multiples of 6 between 0 and 30. So multiples of 6, I'll just do multiples of 6 between 0 and 30. Between 0, let me use this, and 30. While Q is equal to multiples of 4 between 0 and 30. Now, they want us to find this, and I want you to look very well. P union Q complement. They want us to find this. This is what they want us to find. P union Q complement. So if you follow me gradually, I will relay this again, and I will just go into solution on the other side of the screen. Even numbers between 0 and 30, so you should have it at the back of your mind, is that you have 2, 4, 6, 8 continuously until you get to 28, not 30. It say between, not from 0 to 30. So if you are doing from 0 to 30, you're already wrong. It has to be between 0 and 30. So it means 30 is not included. 30 is not included. It's between it, not up to. So please note that, very important. And then multiples of 6 between 0 and 30, I can easily write those. And then multiples of 4 between 0 and 30, I can also easily write those. So let's quickly go into them. So my P will just be all the multiples of 6 that I can think of between 0 and 30. Of course, I know you know them all. So you have 6, you have 12, you have 18, then 24. These are the multiples of 6 between 0 and 30. Now, multiples of 4 between 0 and 30, that is Q. And of course, this one is a bit much. 4, 8, 12. You have 16, you have 20, you have 24, and then you have 28.